Bright QT. Every student matters.
Hello dear students, our next topic is, now we will be talking about circuit diagrams. Now what exactly are electrical circuits and what are circuit diagrams we will be studying in this particular topic. Fine. First of all, we need to relate that what exactly is the flow of current and in which direction we take it. Now in earlier times, always we related that whatever is at a higher potential, fine, all the things always are considered to move from a higher potential to something at a lower potential. Now what do I mean by saying this? Try to relate please. If there is something which is in excess quantity or amount at this particular level, always it is going to flow, anything it may be, it is going to flow from this higher level to lower level. We may talk about liquids like this, we may talk about money like this, we may talk about education like this. Fine. A higher educated person, a person having more knowledge will give knowledge to a person who is at a lower level. The person who is rich at a higher level having more money will give money to that person who is at a lower level. Same is the case when we considered the current. When the idea of flow of charges was taken into consideration, it was considered that current or charges will always flow from a higher terminal or a higher potential to a lower terminal or lower potential. Fine. Anything which was considered to be at higher potential or higher terminal is a positivity. So we always thought that it is a positive terminal and the lower terminal was the negative terminal. So we always took into account the direction of current, the flow of current to be from positive terminal to negative terminal. Now this is the conventional flow that we have been following. This is the conventional or the traditional flow of current which is always shown from a region of positive terminal, higher terminal to a lower terminal or negative terminal. But later on with technological advancement, we got to relate that actually the current is related to the current of electrons. The electrons, the negatively charged particles, they are actually moving because of which current is flowing. And the electrons, they always move from the negative terminal towards the positive terminal. So if we talk about the flow or movement of electrons, that is always considered from, or it is always from negative to the positive terminal. So by this we relate that the flow of electrons is actually opposite to that of the flow of current that we have been following traditionally. Now a closed setup where the current is flowing, that closed setup is known as electric circuit. For example, in our houses we say that when we switch on, right, there is wiring, the electrons will be flowing or the currents will be flowing, and from that switch through the wire they will flow to any electrical appliance, whether it is a tube light or bulbs or air conditioners or fans or anything, causing them to rotate or to move or to function, right, or to light up. So that closed setup is known as electric circuit. Now if we want to show that setup, it is not convenient to draw the AC or to draw the fans or tube lights. So what we do is, in physics, in order to relate it theoretically, we use certain symbols to represent those electric circuits or to represent the components of electric circuit. Now, what exactly these symbols are, let us see. These are a few symbols that will be used. Fine. So, these are the symbols of some commonly used components in circuit diagrams. First of all, we will have a cell or a battery. Now, a cell will be providing the current. Fine. This cell is represented like this. It is represented with this particular a big line and a small partition. This big part is known as positive terminal and this is known as negative terminal. This is one cell. Fine. But if we connect 2 cells or 3 cells or 4 cells, then we call it a battery, which is a combination of cells, right. So, this is one cell. In continuation, we have connected this second cell and in continuation, we have connected this third cell. So, this is a battery of first, second and third 3 cells. And now, what we will and how we will express is that we will just put a positive mark here and the negative at the end, not in between plus minus, we do not write like that, just at the ends. Got it? And we need to remember that positive negative is connected with positive and negative, right. We do not just represent it in the opposite way, negative or positive are not connected. Fine. Then this is the representation, the brackets of a plug key or a switch. Now, this switch is basically the representation is of open switch. Open switch means that now at the moment the current is not flowing through the circuit. But if we switch it on, right, if we plug it on, then that closed switch is represented same like that bracket and we put a dot in between. Now, putting this dot means now this switch is closed, means now the current is flowing through the circuit. Fine. A wire is represented just by a straight line. This particular representation shows that this is a wire joined, 2 wires are joined over here. Fine. This particular representation is how we show that these are 2 wires which are going without joining or without touching. These are the wires crossing each other. Fine. This is how we represent an electric bulb. Now, this is at the moment a bit important, just try to relate. This is the zigzag representation is that of a resistance. Now, this resistance, what exactly is this resistance? In the next topic, we will be talking a lot of details about this particular thing, resistance. Now, this resistance is a fixed one. Right now, just need to remember that this is a fixed resistance. What is resistance? In the next topic, you will be will be discussing it in lot of detail. So, there you will get a basic idea of what this is. This is a fixed resistance and this is a variable resistance. Now, this variable resistance is also represented by this sliding arrow. This variable resistance is also known as rheostat. Fine. By variable resistance, I mean that this arrow, this can be slided up. If I put this arrow here, the value of resistance will be different. If I slide this arrow here, the value will be different. If I slide it ahead, the value will be different. So, this is rheostat, a kind of resistance in which we can change the values as per our convenience. We will study about it later. This is an ammeter, right. This ammeter is basically the instrument which was used to measure current. Fine, we have studied earlier. So, this is an ammeter. Now, this ammeter is always represented as capital A and positive terminal, negative terminal. Similarly, capital V is the representation of a voltmeter, that is a device which is used to measure the potential difference across the circuit. So, these are a few representations how we represent, these are the symbols, right. So, if I am talking about an electric circuit, means a circuit, closed circuit, a closed setup where current is flowing, right. and if I use these symbols in that electric circuit to represent my flow of current in a particular setup, then that diagrammatic representation of electric circuits having representation with these symbols are known as circuit diagrams. Now, what exactly are circuit diagrams? These are the electrical circuits in which these symbols for various components of the electrical circuit are used. Let us see an example of an electric circuit. This is a circuit diagram in which we have just taken this one cell, this is second cell, this is third cell and a fourth cell. So, this is a battery of 4 cells. Fine. This is a battery and this line represents a connecting wire. Fine. This is a resistance placed in between and then there is a bulb attached in continuation. This wire continues. This is K. This is a plug key. We have a dot in between which shows that it is switched on, and if it is switched on means current is flowing, and that current which is flowing from here is shown by the arrows. These arrows show the direction of current, and in our circuit diagrams we always have to show the direction from the positive terminal coming back towards the negative terminal of the battery. Fine. This is an ammeter which is just added up or it is connected. Similarly, this is the positive side, this is the negative side. So, the current is coming like this. Fine. If we want to place a voltmeter also, we will place a voltmeter in this circuit across this resistance. Why we have placed like this? It is of very great importance. This is an important topic. We will be studying it out later in the same chapter, of course. So, this is an example of a circuit diagram where I have shown the closed setup where current was flowing, and I have shown it everything in the form of symbols, like this was the symbol of a battery, symbol of resistance, symbol of voltmeter, symbol of bulb, symbol of ammeter, symbol of plug key or the switch. Fine. This is about our circuit diagrams, right. Now, the next topic is very important. Just try to relate all these circuits so that you are able to just correlate whatever we will be just studying in the next topic. Fine. Just try to relate the circuits and their symbols. Thank you so much.